Okay, let us start today's discussion. Hope it is visible. Okay, so today we will start with an example. Okay, so the joint density of two random variables x and y is provided. The joint density of x and y is provided, where x and y are two random variables. Okay, so what is given? F of xy is x plus y whole square by 14 for -1 less than x less than 1 and -3 less than y less than 3. Okay, and for any other value it is 0. Okay, now question is, find the variances of x and y. Of x and y. So this is our first question. Okay, Okay, so let us solve this question first. So the question is, the joint density of two random variables x and y is given. Find the variances of x and y. So what we need to do at first, we will calculate x bar and y bar. First we calculate x bar. Why we need to calculate x bar? Because to calculate the variance, we need expectation of x square minus x bar square, right? So first we will calculate x bar. Okay, so this is as this is the limit, we will directly put the limit. X is equal to -1 to +1, and y is equal to -3 to +3. Okay, x into f of xy. So let us directly put the value. The f of xy is given to us. So can we write it as x plus y whole square upon 40 dx dy. Okay, now the thing is that what will be the value of this integral? If we calculate the integral value, we will get 0. Why? Because this is a odd function, and it is -1 to +1, and it is -3 to +3. So directly we will write that it is 0. We can calculate also, right? Similarly, if we calculate y bar, then what will we get? We will get again x is equal to -1 to +1, y is equal to -3 to +3. Similarly, y multiplied with x plus y whole square upon 40. Dx upon dy, and its value will also be 0. You may calculate. Okay. Now we will go to expectation of x square. expectation of x square is similarly it will be x is equal to -1 to +1. Y value is y is equal to -3 to +3. Value is given here, right? And it will be x square multiplied with x plus y whole square upon 40 dx dy. So is there any other way we can calculate x bar, y bar, and expectation of x square, expectation of y square? Yes. First, if we first calculate the marginal density, then also we can calculate, right? Although both are similar. So this value will be 1 upon 40 let us write it as y is equal to -3%. Double integral x is equal to -1 to +1, and what will be this value? This will be x to the power 4 plus 2x cube y plus x square y square, right? X square y square dx dy. Let us do the integration with respect to x first. Then it will be 1 upon 40 y is equal to -3 to +3. What will be this value? If we integrate it with respect to x, then we will get x to the power 5 upon 5 plus this will be x to the power 4 upon 4, so we can write it x to the power 4 y upon 2, right? Because here 2 is multiplied, plus x cube y square upon 3 for x is equal to -1 to +1 dy. Okay. Okay. So now let us put the value. This is 1 upon 40 y is equal to -3 to +3. So if we put 1, we will get 1 upon 5 plus it will be 1 upon 2 plus this will be y square upon 3 minus this is minus 1, right? So this will be minus 1 upon 5 plus y upon 2 minus y square upon 3 dy. Let us simplify it. It is 1 upon 40 y is equal to minus 3 to plus 3, and this is 2 upon 5 plus 2y square upon 3. Is it understandable? Dy. If there is query or anything you are not getting understood, then please ask. So this we can write 1 upon 20 this is y square, y is equal to minus 3 to plus 3 1 upon 5 plus y square upon 3 dy. So we can write this is 1 upon 20 this will be y upon 5 plus y cube upon 9, limit is from minus 3 to plus 3. This is 1 upon 20 okay, so this is 3 upon 5 plus 3, right, minus 3 upon 5 minus 3. So basically it becomes 1 upon 20 multiplied with 2 into 18. So what we are getting, we are getting 0.36. Okay, now in the similar manner we will calculate expectation of y square. So this is again this x plus y whole square upon 40, right? So 1 upon 40, y is equal to minus 3, 2 plus 3, x is equal to minus 1, 2 plus 1, y square multiplied with x plus y whole square dx dy. Okay, is equal to 1 upon 40 y is equal to minus 3, 2 plus 3, x is equal to minus 1, 2 plus 1, and this is x square y square plus 2xy cube plus y to the power 4 dx dy. So in the similar manner, let us calculate the value. One upon 40 y is equal to minus 3, 2 plus 3, this is x cube y square upon 3 plus this is x square y cube plus x y to the power 4. And x is equal to minus 1, 2 plus 1. Dy. This is 1 upon 40 y is equal to minus 3, 2 plus 3. If we put the value, we will get y square upon 3 plus y cube plus y to the power 4 minus, if we put x is equal to minus 1, we will get it minus y square upon 3 plus y cube minus y to the power 4. dy. This is 1 upon 40. We will get y is equal to minus 3 to plus 3, 2 into y square upon 3 this will be cancelled out and it will be plus y to the power 5, sorry, y to the power 4 dy. So this is 1 upon 20 this will be y cube upon 9 plus y to the power 5 upon 5, and the limit is from minus 3 to plus 3. Okay, so let us see what is the value. This is 1 upon 20. If we put 3, then what will we get? 27 upon 9, right? So it is 3 plus 3 to the power 5 means 243. 243 upon 5 minus, it is minus 3 minus 243 upon 5. So what we are getting, it will be 1 upon 20 multiplied with 2 multiplied with 258 upon 5, right? So what will we get? This is 5.16. Fine. So our question was calculate the variance. So variance we define sigma x square, right? Where sigma x is the standard deviation, and this is expectation of x square minus x bar whole square is equal to expectation of x square, what we have calculated, 0.36 minus 0. This is 0.36 and sigma y square is equal to expectation of y square minus y bar whole square. This is 5.16 minus 0 is equal to 5.16. Okay, so the first part, this was the first part of this question. There is part 2 of the same question, that is find the correlation coefficient. Find the correlation coefficient. So let us try to solve this. Okay, so correlation coefficient, we know we define it rho of xy, right? Is equal to c of xy divided by sigma x multiplied with sigma, where cxy is equal to expectation of xy minus x bar y bar. So first we will calculate expectation of xy. So this will be 1 upon 40 y is equal to minus 3 to plus 3 x is equal to minus 1 to plus 1 xy x plus y whole square dx dy. Okay, so let's solve this. This will be 1 upon 40. Y limit is y is equal to minus 3. Two plus 3. X is equal to minus 1 to plus 1. This is xy. X square plus 2xy plus y square dx dy. This is 1 upon 40. Y is equal to minus 3 to plus 3. X is equal to minus 1 to plus 1. X cube y plus 2 x square y square plus x y cube dx dy. 1 upon 40. Y is equal to minus 3 upon plus 2 plus 3, and this will be x to the power 4 y upon 4 okay plus this is 2 x cube y square upon 3 plus x square y cube upon 2. X is equal to minus 1 to plus 1 dy. This is 1 upon 40 y is equal to minus 3 to plus 3. So let us put the value of x. This is 1 upon 4 plus y square upon 3 plus y cube upon 2 minus, put the value minus 1, 1 upon 4 minus y upon 4 minus 2y square upon 3 plus y cube upon 2 dy. So it will be 1 upon 40 y is equal to minus 3 to plus 3. This will be cancelled out. This will be 4 y square upon 3, and this will be cancelled out, right? Dy. So it will be 1 upon 30 if we multiply 4 by 3 with this, right? And it will be y cube upon 9 so its value is minus 3 to plus 3. So this is 1 upon 30 3 cube upon 9 means 3, right? Minus of minus 3. This is 6 upon 30, which is 0.2. Okay, so rho of xy, before that let us calculate c of xy. It is expectation of xy minus x bar y. Our expectation of xy is 0.2 minus 3 is equal to 0.2. So rho of xy is equal to c of xy 0.2 divided by rho x into rho y. Rho x is 0.36, root of 0.36, right? 0.36 multiplied with 5.16. So what will be the value? Let us calculate. This will be 0.2. This is 0.6 multiplied with 2.27. So the final value is 87.15. Okay. So this was the entire problem. Now we will go to the next problem. This is a very interesting problem. Example 2. Again the joint PDF is given. It is given as 1/8x plus y for 0 less than x less than 2. And y value is not given, right? So we consider y minus infinity to plus infinity. Or it is given, let me check. Yes, both are given. And 0 otherwise. Question is find conditional density function. First we will calculate the marginal density. F of x is equal to minus infinity to plus infinity f of xy dy. Y limit is 0 to 2. So this is 1 upon 8. Dy. So this will be xy plus y square upon 2 0 to 2. Y value will be 2, right? So x plus 2 is 2x minus 0 plus. So it is 1 upon 4 x plus y, and condition is 0 less than x less than 2. So conditional density f of xy y upon x will be f of xy x comma y upon x f of x, which is equal to value is given it is 1 upon 8x plus y. And f of x we have calculated 1 upon 4, which is equal to and the limit is given 0 less than x less than 2, 0 less than 1 less than 2, and for any other value of x and y it will be 0. So if x y y upon x is equal to x plus y upon 2 into x plus 1 0 less than x less than 2, 0 less than y less than 2, and this is 0 for else. Okay, now in the similar way we will calculate marginal density of y. If we use the same way, then it will be just simply 0 to 2, because the limit is 0 to 2 and it is 1 upon 8 x plus y. Instead of dy it will be dx. This is x value, right? This is simply 1 upon 8 x square plus xy x square upon 2 plus xy 0 to 2 1 upon 8, so we will get 2 plus 2y minus 0. So in the similar manner we are getting it 1 upon 4 y plus 1 for 0 less than y less than 2. So if we calculate f of xy, x upon y, this is f of x comma y f of y. It is given 1 upon 8 . x plus y and upon 1 upon 4 multiplied with y plus 1. So what we are getting, x plus y upon y, 2 cross y plus 1. So similarly we will write it like this. F of x y, and this is x upon y, x conditioned on y, right? Is equal to x plus 1 upon 2 multiplied with y plus 1 and 0. This is for 0 less than x less than 2. This is for 0 less than y less than. The same condition is for. Okay. Okay. So this is the final solution. So let us stop here.